Well, hi, good morning. Thanks so much for joining me in my shop here. This radio's in pretty darn good shape now, except I think I could hear some distortion when I played it yesterday. So I think a smart move next would be to do tube testing. I'm going to guess this tube is bad. That's my guess. Well, we'll do all of them. I mean, we'll start here with the rectifier tube. And I'll be testing these in the Weston 981 tester that I have. So this is already set up, but let's double check. 35Z5, 35 volts for the filament. Signal not used because it's a rectifier. Bias not set. And then we have here 07003, 07003, and then 0610. Okay. Sensitivity 23, and the plate is set to E. We're good to go here. Pop this guy in. Switch on. So if this by some chance is your first time seeing tubes tested, the first normal test in a tube tester is to check for shorts in the tube. Now, I mean, this radio's been working, so I don't think any of these tubes have shorts in them. But that's in order to protect the tube tester. So we're going to go through the short test here. We just watch the meter. So it did not come up. There's no leaks or shorts in the tube, so it's suitable for testing. And we test it by rectifier and diode test. So rectifiers have to come above this little spot here on the dial. Okay, I think we're ready now. Here we go. So it's way up in the rectifier good range. That's the entire test for a 35Z5. Good tube. Make sure I turn down the filament voltage right away. Although the next tube we're going to test has an even higher filament voltage here. The filament voltage for this guy it's a 50L6. Guess what? It's 50. Looks like 47 here. Set that there. Now see if I can find a 50L6 on here. 50L6 right there. Filament 47. I wonder if it really is 47 volts. Signal set to 8. Bias set to... Wait a second. There we go. Bias set to 18H. 18H. The numbers are 07345. 07345. 0610. 0610. Same as it was. Sensitivity 43. That makes the meter accurate. Plate is on C. So we want this to come up above the 1030 mark. So up above here. Filament's 47, right? Good. So this tube could be responsible for some distortion. More likely not the tube, but the tube's biasing that might lead to some distortion. Okay, let's look for shorts. Okay, now ready for the GM test on here. Here we go. Let's take a little closer look. Supposed to be above 1030, so it looks like to me like it's right on 1030. So I would certainly not qualify this as a bad tube. It's a small radio. Doesn't need a lot to drive its speaker. Yeah, a tube test like that, I would never reject a tube like that. So next one is the 12SQ7 detector tube. 12SQ7. Let's just see if I can't remember. I have cameras running here. 12. SQ. So it's coming up. There it is. Two-part tube. On this tube tester, the 12-volt tubes get a 13-volt setting. Signal 1, 18L, that's 18L, 251, 12SQ7, 12SQ7, 25100, 25100, 3760, 3760, 37 sensitivity, F for the plate. So in this case, we're checking the triode side of this tube first, and it should have a GM of 760 or better. 760 is down in this area here. Okay, we have the correct filament voltage. Okay, shorts. Oh, oh, oh. What was that? Some tubes have notes, but I'm sure this one does not have a special note, because some tubes will show shorts. Right? It's a complete short. This is a leak. This is actually measuring a resistance between elements in the tube. Right now, no, there's no special note here or anything about it. Okay, let's keep going here. Doesn't look too good to me. 12SQ7. Maybe this is the cause of the distortion right here. Not much use testing more of this tube. I think I'm better off to go right away and get another 12SQ7 and see if it tests the same way. I'm sure it won't, though. You know, maybe this is it. Maybe we found it already. Okay, so I have a box, here they are, of 12 SQ7s, and you see how they all have a number tag on the top. All these tubes have been tested. I've been doing a lot of tube testing in the background. So let's take a look at the results in my records here. Okay, so this table requires a little bit of explanation here, but when I did this, I was really trying to compare a number of tube testers against each other and come to some grip on how they worked. So one of the things I realized is each tube tester gives you target numbers for the tube that's being tested. And those target numbers are based on how the tube is being tested in that particular tester. So often this is in the GM test, the transconductance test, or mutual conductance test, whatever you want to call it. And there'll be some numbers there that you have to get over in terms of the GM reading and the like. So those numbers are written up here. So take a look. This is one tester, the Stark 9, my 966 Stark tester here. For this tube, 12SQ7, the bottom test you must reject at 630. You should expect it to be around 1,000. That's how I interpret these numbers. So 630, she's garbage. 1,000, she's good. So on the Weston, you're just given a number for when you should throw it out. And the number is 760 on the Weston. And then these are diode tests, just skip those. When you come here, here's an ICO. This is the ICO tester that it's not a mutual conductance tester, it's a emissions tester. So this is just basically testing the cathode to make sure it can still emit electrons at an acceptable rate. That's what this test is really all about. The number here is percentage of good. I think that's the way you look at this. So this tube, the first tube, which is, we'll go across it in a sec, tests 92% of good. Am I interpreting this exactly right? The 55 here is kind of the middle of the good area. You know, it goes from 0 to 100. 55 is kind of the top of the good. So conceivably, anything over 55 is a good tube. You just look down this list, and the numbers are all pretty good, really. So you get way down here. Here's one, a couple of testing in the 60s. Just look over. Those two tubes barely operate. These are barely operating tubes. These are the tests on the other two tube testers. It's still in the good on the ICO tester. So that's something to keep in mind. My ICO emissions tester is really generous. So we'll just ignore this from now on. In fact, I don't use this tester. Anyway, why would I? I have these great testers over here. So let's take a look at the first two. We'll just compare them quickly. This is kind of a test of the testers. So I don't think I calculated the percentage here, but we could look at this as the percentage of the result against the target. So, and we pick the reject target because that's what we've got on both of these. We'll take a look right away. Oh, 1100 is double, roughly double 630. 1400 is roughly double 760. You can go down these like this and you'll see the ratio is maintained all the way down through all these tubes. There isn't any case where you get a tube testing bad here but good there. They're all going along quite similarly. So that's great. So what this tells me, and what I learned from doing this, is if you're going to quote the GM measurement on a tube tester, you need to state the name of the tube tester, the make and model. This test was done on a start of 966, and you need to quote these numbers for comparison. Without that information, just stating I put a tube in my tube tester and I read 1200 GM, it's just meaningless. It just doesn't. It's just not going to do it for you. Now, on the flip side of that comment is this one. The tubes kind of work or they don't. It's really, yes, tubes get weak. It's true. But to a large degree, what you're really looking for are dead tubes, totally bad tubes, stuff like that. And of course, the ICO is going to show you that. All these tube testers are going to show you a really dead tube, like with an open filament or something egregious like that. Okay, which tube are we going to use? Well, this isn't the greatest radio in the world. Let's go down and pick one. So this would be my best one right here. Here's another good one. Oh, a whole bunch of them. I got my pick. So let's pick, why don't we pick number 14? Okay, we'll pick lucky tube number 14. 25100, 2510, yeah, we're still set up here. 3760, 3760, yep. Pop them in. Now the last tube showed a short on tube test 5. Okay, here we go. Yes, there's no short appearing on this one, so there's definitely a difference here. And the GM supposed to come up to 760, up above there. Oh, holy smokes! It's way up there. Perfect. That's our tube. Okay, we'll put this in the radio, and then we're gonna have to give the radio a try right away, pretty well. Let's see if this was the guy. Yeah, I have 20 12 SQ7s, and that's because of some lucky tube purchases from people who were collecting very specific tubes. I managed to buy their collection and score a curated collection of tubes. I did that a couple of times now, successfully. Okay, everything ready to go? I think so. Volume down. Dim lights. Doing its thing properly. Now this was about hearing distortion. So that's what we're going to do. We're going to listen for distortion here. Patience. Okay, well, okay, so what I'm listening to, I still hear a little bit of distortion, but it could easily be the speaker, and it can easily be insurmountable, easily. But we got two more tubes to test, and I still think the 12 SA7 back here, I think that guy there, I think he's a bad guy. Let's get to him and give him a test. Okay, so just before we change the settings here, let's just pop the shorted 12 SQ7 back in and see for sure if it really does do that. It was on this spike saying, hey, where'd it go? What happened there? Oh, it's warming up. I saw it there. Oh yeah. Okay, so this is a dangerous tube because it can test both good and bad. It can test good and be bad. So this one's going where it can never get mixed up again with good tubes. Okay, so the next tube we want to do is going to be the IF tube, which is pretty warm now. 12 SK7. 12 SK7 here. There. Filament 13. Signal 2. Bias 10L. 10L. 17251. 17 251 4630 4630 44 C. Very important you get this set correctly. C. That could be why they brought this out on its own control here, to make it really stand out. You know, throwing the B plus onto different pins with this control. That's how I understand it. Reject point 1520. Pen is a pentode. 1520. 1520 is, well, it's about dead center of the scale here. Okay, double checking everything. 12 SK7, 12 SK7, 13.2, 10L 17251, 17251, 4634, 630. Okay, we're ready on the runway. Well, I'm going to take a wild guess that this tube will test just fine. How long it takes that radio to warm up. Exactly which tube it is that's taking forever, I'm not sure. Could be some kind of differential heating. Maybe all the other heaters are going first. Does that really make sense? I'm not sure it even makes sense. Anybody leaking? No. Small rise in this pointer doesn't indicate a problem. GM up to the middle. Oh yeah, she's a good one. Okay, so now we're going after the one I've been suspicious of. And why am I suspicious of this one tube? I will tell you why. It's a glass tube. All the rest of the tubes are metal tubes. Why is this glass one in there? There's no shield on it. Although I think this, when you see it dark like this, that's an internal shielding. Made in Italy. Admiral. Made in Italy, it says right in fine print. 12SA7, yes it is. I just like to make absolutely sure it is what I think it is, because once in a while, it's not. 9L. That's my clothes washing machine singing its happy song. 27345. 2, 7, 3, 4, 5. 1650. Just a little dark in here for me. 1650. Sensitivity 45. C. Reject point is just above 1,000. Just above 1,000. Old tube getting tested, whatever that means. Okay. 12. Ready to go. Now. This is the guy I figure is going to be bad. I'm just guessing, of course. Okay, short test. No shorts appearing. GM, once again, 1100, just above 1,000 here. Look at that. Should test great. Okay. Well, that's the story on that. Okay, so I think the question has come down to, is the distortion coming from the speaker, which I can't do too much about, or is the distortion, or whatever it is I'm hearing, is it coming from some electronic problem like bad biasing on one of the tubes? So I can do something about that. It's pretty hard to fix a distorting speaker. And the sound, I can't really be sure. So what I think I'm going to try, since this radio comes with, voila, a phono input, I'm going to feed a nice clean audio signal in here, and we will listen to what's coming out. And something about these guys. Often on this kind of radio, or many radios, pushing a plug in here also operates a switch simultaneously. I'll show it to you. So this is actually a switch. I kind of forget about this sometimes. Let me get that just a little better. Let me get a better camera shot of it so you can see it operate. Okay, now this is one of the first times I've taken a really close look at one of these switches myself. So let's operate it. All I'm going to do is just push in the phono plug and watch what it does. See it? See it? See it push that? A little further. See it separate the upper ones here? Just barely though. This is a short. Like, this is typical of what people are used to seeing, but back in the day there were a lot of them that looked like, oh, crying out loud. Look like, wait a minute, I had like 5 of them in front of me here just a second ago. How can this be? How can this happen? Here we are. They look like that. Whoa, holy smokes. There's a difference. So this long one, of course, when you watch it come through, this is a crazy long one. This is really longer than, just looks like everything is shorted together with this one. Maybe this one is too long. I think it's supposed to do that and not much more. Okay, let's give it a try though. If it's not working, then we can suspect that this hasn't worked so well. Good show. I'm using an audio wire. Good choice, Jim. Okay, now, so we're gonna feed a signal in. We're gonna feed it in from this signal generator here. Signal will be quite a low level to start off with. And we should have it set to around 1,000. Okay, that's pretty close to 1,000 hertz. Feeding into here. So as soon as I turn this guy on, this is what we should hear. I don't know about the volume controls and all that kind of stuff. So we will be cautious here. Once again, volume's turned down, power on. I think there's a really good chance that the distortion is the speaker itself. But let's see what we can find out from this arrangement here. I better turn it up a little. Whoop. There it comes. Sounds like a radio to me, doesn't it? Ooh. I think this didn't work right. I think that's why we got this hum. That sounds like an open circuit front end. So I don't have many chords with the longer piece. I'm gonna have to see if I can find one, or we'll have to do this some other way. Okay, so feeding in an audio signal didn't work out. I can't find a chord with a long enough tip on it, so heck with that. I'm back to just transmitting a signal to the radio, so it's going to pick it up like any signal coming from the signal generator there. I'll be in this loop of wire, which will be near the antenna. I try to overwhelm the radio with the signal coming from the signal generator, so it's not very noisy, and then we can take a look at what it looks like on here. Fiddle around and see if we see any flattening or anything at all that might give us a hint about the distortion that I think I'm hearing. Or maybe we'll find out that it is all the speaker itself. So I think we're all set to go here. 1400. Oh, let's turn the radio on. 1400. Let's see how well I tune this radio. It's a fairly low signal, not directly connected, right? It's going in this loop. Let me pump it up. Pump it up one step. One step. Hello. That's quite the volume control you got there, champ. Okay, now on the scope, pretty interesting. You know what? I gotta get a better camera onto that scope because it's showing us something interesting here. Okay, let's take a closer look here. It's on the scope. Now, my scope doesn't trigger very well here. Oh, let's see if I can get it to trigger. Come on, man. So, now that picture just looks terrible on the camera. Very tricky to get nice camera shots here. So I can fix the trigger here. It's not going to trigger cleanly on this, I'm afraid. But what you can certainly see is that this is not a single line sine wave. It's all filled in. What's it filled in with? Yeah, the picture looks just terrible on the video, but I think you can get the idea. This should just be a single line going up and down. It shouldn't be filled in. And this is coming right off the speaker. Well, that's telling me something right there. I think. Wow. Yeah, the signal is really high coming into the radio. Oh, maybe that's part of the problem. Maybe the signal is just ridiculously high. Well, then look at this. Again, I apologize for the quality of the image there. Let me see if I can make my camera do its thing. So again, why is this filled in through here? Terrible looking thing. Let me tune in a station. Hey, where did the band go? This is the upper end. Again, I apologize for the terrible image. This is the upper end of the band. 14. This is the lower end. Ignoring the funny, sneaky shape there. So tune up. So this particular signal that we're listening to, it looks to me like you can see it comes up a short ways here, maybe halfway above the center line, but it goes right off the screen at the bottom. Yeah, it's roughly, well, where is it centered? There. It's centered right on the line. So in fact, yeah, it is coming up about halfway, but it's going right off the screen at the bottom. That's pretty imbalanced. That suggests a biasing problem in the radio. We haven't checked the output tube biasing yet. Okay, maybe that's the next thing to check then, is biasing, actually tube biasing all around. Let me get ready for that. Not sure what all the noise is about, but let's pay attention to voltages right now. In fact, let's turn this right down. So, I have to refer to my tube manual every time. 50L6. Let's see what it says here. Grid is 5, plate is 3, and there's a screen and screen. Can we remember all this? So it's 3, 4, 5, plate, screen, grid. 3, 4, 5, plate, screen, grid. 3 output tube is this one. 3 would be this one right here, I think. Okay, so my meter's on the 150 volt scale and we're reading only 70 volts. Seems a little low. Okay, we'll go over here. Ooh, careful there. That's the screen. 40 volts. Boy, that does not seem right. And then the grid. The grid is showing positive here. Really? No, that's not good at all. 15 volt scale. I think the grid is... Did I switch tubes? I got on the wrong tube, didn't I? Oh, man alive. Let's go back here. Just do this again. 1, 2, 3. Plate. Screen. And then grid. Maybe I didn't do the wrong tube. So the grid is showing a positive voltage here. Just what we saw. 50 volt scale. Grid. So that's a very, very bad thing. We don't want a positive voltage there. How is that happening? I should really read it from cathode to grid to be sure. I'm not going to do that with this kind of meter. I'm going to do it with my completely independent multimeter here. So this test should yield a negative voltage of some amount. Put them here. Cathode. Grid to cathode voltage. Cathode is 8. Yeah, 50L6. 8 versus 5. What's the voltage between 8 and 5? What is the voltage? 8. 8 is here. 5 would be 1, 2, 3, 4. Okay, so we see a positive, a tiny positive voltage. I have so what is positive is the cathode. The cathode is slightly positive to the grid. That's what we want. But it's not much of a voltage there. I don't know if that's ABC controlled or not. Should there be a grid bias there? Of course, a 50L6. Okay, let's study this up. I forgot I'm looking at the output tube, so this is pretty important. Let's study up on the output tube circuitry and see a little more about what we really should expect here. Okay, let's take a look at the schematic here and we'll see how they're doing things. First of all, these tubes are shown sideways from your regular tube position, and I believe they've got the wires coming up to it. You can see that little black thing right there. So I believe this is the order of the pins. So it's pin 1, pin 2, pin 3, pin 4, so on, and then you can hardly see it. The very light lines drawn inside the tube connecting, where the wire comes to the element in the tube. These are not easy to see. This one, not easy to see here. And so But this one I know for sure is the cathode connection right here. Cathode, and what do we see? We see a resistor coming down to the B plus line. This is the B plus line here. And so R11 is probably a cathode resistor of some hundreds of ohms, and then this C22 is probably a big capacitor. So let's take a look. R11 C22. Let's come up here, and R11. Holy smokes! 150 ohms, 1 watt. So that's exactly what you'd expect to find as a cathode resistor. So we got to find that resistor, make sure it's still 150 ohms, and then the capacitor C22. Oh, it's part of the 3-part, actually 4-part capacitor in this radio, part of which has been skipped over. I think maybe this is bad. Maybe this part's got to go too. So 22 is almost certainly the 20. So it could be the bypass is not working properly, and it could be the resistors not correct. And the last thing is, we gotta go back to the schematic. Oops, up this way. How is the grid protected? Okay, I'm gonna zoom in, but hang on tight. Computer goes a little weird. No, did okay. Now you can see those light wires up in here. So the grid is here. So R12 is probably a very large capacitor, and this one, C25, is the blocker from the plate over here. So this plate, hey, look at the voltage, 70 volts, 105. A little low because I was measuring like 70 and 40 here. So that's probably a good source of all these problems too. You know, Jim, you should really pay attention to that maybe. Okay, let's stick with one thing. We'll finish off checking this tube's operating componentry. R11. Let's find R11. Because there's a picture of R11 in here. I gotta shrink this here. R11. So R11. R11 is right in there. Okay, I'm just gonna look away at the radio for a minute. Oh yeah. Well, there it is. Yeah, 1.5. Yeah, brown, green, brown. Looks to be in perfect shape though. So we're going to check that. And we already know this capacitor hasn't been the greatest. That one that's in there. Good. Okay. Right. Let's check that. Ohms. That resistor's right here. This big one, you can see it quite clearly. Whoops, just at the exciting moment there. $150. Right on the money. Leaky bypass. It's only 150 ohms here. Leaky bypass capacitor. And what is the proper? So that's the proper bias resistor. Why was it looked like the voltage was tiny on it? Why would that be? Let's just take another look here. 50 L6. Maybe we'll get a hint out of the book here. 50. It's a big number, Jim. Come on. 50 L6. What does it say about it? Plate voltage 200 max. Oh, 50 L6 really meant for these 5-tube radios, I guess. 125 screen grid max. Grid number 2 input. in watts. It's an interesting way of putting it. Grid number 2 is the screen. Peak heater cathode voltage. Heater cathode voltage, that's something else. 150 volts, typical operation. Here we are, grid number 1, control grid voltage, -7 on fixed bias. Cathode bias, they don't say anything, of course, but if we go down to cathode bias resistor, it suggests a 180. And the plate current is almost 50 milliamps, 50 milliamps really. You have 50 milliamps flowing through 150 ohms. That should give you, I should read the voltage right across that resistor. That's really how I should do this, maybe. Total harmonic distortion, 10%. 10%. Maybe that's all it is. So we'll turn it on, we'll read the voltage drop on the resistor. Power on. So even though it's a positive reading, it's just the way I have the leads. So we're getting 5 volts, and the supply voltage is 112 to the radio. So if we throw the whole 120 in there, this might go up to, I don't know, maybe 5.5. The thing is, where'd it go? What happened there? Five is not far from 7, and it's certainly not 0. The capacitor that's blocking it, I forgot to look on the diagram which one that is. That was C, I can't remember. Let me just quickly look here. And the blocking capacitor is C25. C25. I'll now locate that in here. Just bear with me a moment while I do that. Come on, C25. Okay. So C25 is this one down here. This guy right here. So he's got an important job. He's holding back high DC voltage. So that might be one I really need to change. So let's just read this voltage again between the grid and the cathode, because I don't understand why I didn't see 8, or 5 rather, 5 volts there. So grid. Cathode. So the reading is negative. So the positive lead is the black one now. So this is showing the grid relative to the cathode. Only 0.2 volts. So I don't know, can this capacitor really, maybe it can push the voltage, allow a leak of the plate voltage onto the grid of the output tube. Well, let's try changing that capacitor and we'll see what happens afterwards. I think that's the way to go. I'm running my soldering iron at 310 degrees, which is still kind of low for this kind of work. But it seems to be doing okay. For a few videos there I was running it stupidly low at 200 and something degrees. Let's test this guy I just took out here. 0.05. $50, just like all the rest. Certainly, that's 3 for 3 now. Seriously leaky capacitors. If they can't sustain 50 volts on that tester, then they, compared to many other capacitors I've tested, these ones are not doing well. They look nice, but they're not. They're very deceiving. I've had the opposite happen, where I've had capacitors that look terrible all test really good. So I'm pretty sure we're on our way to doing them all. What's left? 3 more. So let's see what happened with this. With this one. Sounds even better. Reduce the signal strength there. Let's try that. Ooh. Good job. Let's go even lower. Okay, now this would be, well, the way I've got it connected here, I can't really say for sure. Lovely. So now I can hear the S's in the person singing there. Before, I don't think I heard any sound come out. It was not getting reproduced for whatever reason. Okay, well, we're doing really good now. What would possibly prompt me to change even more? Aside from the fact they all test poor. B+. It was low. Let's measure it again. There we go. Took me a while to get stuff in my hand here. 150 plate was, wasn't it 345 on the output tube? Wasn't it? 0.03. So now we're reading on the 150 scale, reading 80 volts. Let's give it full voltage here. 50, screen, 90 plate. So I think what I want to consider doing now is changing more of these capacitors, but the ones that are tied in with the front end of the radio. So that there's a large one here, and quite a large one here. 0.03 there. This is a 0.025. This is probably a 0.02 or a 0.1. 0.05 or a not 0.1. 0.01. Let's go for this guy. He's involved with the tuning capacitor here, this coil here, just on that basis. It's a big one, 0.03. Yeah, let's do that one next. We'll do that. Okay, so 2 more capacitors done. I've got the across the power line one here, and then I changed out this capacitor, which was running back in here. And let's check them. So first of all, the one that was across the line is this 0.025. I have to think the only reason it's there is to stop RF from coming in on the power line. 50 volt test. Hey, look at that. 150. Can't do it at 150. So a little better. That thing was probably seeing 120 volts AC, I think, every time the radio was operated. Maybe even when it wasn't. I'm not exactly sure what this capacitor was doing. 0.05. 50 volts. So all these capacitors are testing in such a way that they probably wouldn't drag down the operation of the radio terribly, but and maybe collect, every individual one isn't really knocking the radio out, but collectively maybe they are. Let's try it out again. Here we go. Okay, dim bulb doing its usual thing. There's only one more capacitor left, and that's the capacitor on the volume control slider. I think that's the last one that's left here. Boy, you got to be patient with this radio. No more RF. Tended to find it up at the high end. Let's go up there. Oh, you can't even see that. There we go. Sorry about the volume there. I'm sure it's just blasting on the video here. Let me crank it down a little bit. Oh! So what I'm seeing there on the scope is the RF appears to be gone now. But now I'm noticing that there's more in the upper half than there is in the lower half. As if if there was a biasing problem, it's gone from one way to the other way. That's what it looks like. That's what it looks like. We got one last capacitor to do. Let's do it. Okay, last two capacitors. Now this is the one that the audio is passing through the volume control on. Okay, 50 volts. Does a nice job. 150. Doesn't do the job. They're all coming to be, I mean, they all look very similar, and it turns out they all work very similar. Now, since the last one. Oh, what did I do with the last one? I've gone and set it down. Here it is. Yeah. So this one is involved with the grounding back of the phono plug on the back of the set. If you can think about it, it's a 5-tube radio with a phono plug on the back. How do they do that safely? This capacitor is part of the picture, I think. 50 volts. She's a leaker. There you go. So all told, all of these capacitors which are sitting here, which look pretty good, all of them leaking enough that I think it makes good sense to get rid of them. Especially the one that was blocking the high voltage from the grid. Any leak in that capacitor is going to cause a problem. It's going to burn out your output tube. Okay, so I think, so there's the one I put in, there's another one I put in. There's no more paper capacitors in there. They're all gone. Boy, my intention was to leave them all in there. Didn't quite work out that way. Ready on the power. Power this baby up. Hey, did I just see the light flicker again? Is it just the light maybe flickering? No? Don't know what that was. I saw before. Where'd it go? Oh, there it is. Hey, what happened to it being on 14? So all this fiddling around has changed the local oscillator a little bit. Oh, wait a minute. My signal generator is not on 14. There we are. 14 now. A weak signal I'm sending over. So it's being competed with noise. Okay, let's go. Oh, wow! This guy's got a lot. He's got a lot of power now. Man alive! I need to calm down the volume. Oh my God, I don't care if he was 14. He did blackface. He should resign. I got a photograph of my parents and all their friends in blackface at a party. I mean, I'm not justifying blackface. All I'm saying is 20, 30, 40 years ago, that kind of stuff was done not intending to hurt anybody. Yes, it's culturally insensitive. Of course it is culturally insensitive. But that was then. So the real question is, would you do something like that today? And of course the answer is no. Oh my God. But you know, the media's going to run with this all day long until it gets something else to chew on. Hey, it's the same in Canada as it is in the States, as it is in Britain, as it is everywhere. Everywhere. So, okay, I'm going to throw this guy back in his cabinet now. I'm going to find out what it really sounds like. I won't rant. I'll stop ranting. No ranting, Jim. Okay, so I apologize again if the volume was out of control during parts of this video. A little hard for me to keep my eyes and ears on everything. So we're gonna turn this guy on. He's on. He's an always on radio. So the thing about this cabinet is, you know, it's not bad, but it could easily be refinished. It has sharp edges here. This makes it really easy to refinish this guy because you can use flat sanders and stuff like that. So I think I saw one on the internet where somebody had stained this dark, and it looked pretty dramatic, especially with this lighter panel here. Well, you can hear a touch of a hum. Let's hear it.
Radio 640 Toronto. At the Lexus 3-day event, the offers are only here for a limited time, but the thrill of driving a Lexus is endless. Right now, get a remarkable 1.5% of finance rates for rates as low as 0.4%. Plus, we'll reward you with delivery credits of up to $4,500 on select Lexus models and conditions apply. The Lexus 3-day event only runs until this Saturday. This is your chance to drive home a new record.
So changing the volume control resulted in too sensitive of the volume. So if you turn this up any amount, it's a blaster anyway. So next time around I'll be a little more careful and maybe go for a smaller resistance volume control if I can't match it exactly. I planned on keeping all those original parts in there. I thought I was going to get away with that, but clearly not the case. I had to change one tube out because of that intermittent short thing. So that's the story on this radio. Like I said, I've got two more of these guys. There's a nickname for these. I'm going to forget the nickname. Oh my gosh, how can I forget the nickname? Just in the middle of doing this. And the nickname is the Baby Champ. That's a nickname. So lots and lots of these around up here in Canada. I don't know if they were exported. Probably exported to the States. There's probably some of these down there too. Anyway, there we go. Thanks a lot for watching, and parts are coming in, so I think I'm going to get back on that big radio next. The huge radio. Thanks for watching.